This conference will now be recorded.
So last week we began our discussion on geographical maps, and we discussed how Tableau can distinguish between geographic and non-geographic data using the geographic roles, right? And we also talked about all the geographic roles available with Tableau. We learned how to create filled maps. Filled map is a map where the entire area is filled in with a color, right? And it can represent a maximum of only one measure visually. By putting it on label and by putting on tooltip, you can put as much information as you want, but visually there's only one thing that we can represent, because that is because we can control only the color of the map. Then we learned about how to create a symbol map, and we know symbol map is something where we can represent two measures. We represent the data in the form of a symbol. We can control the color of the symbol through one measure and size of the symbol using another measure. Then we also discussed about how we can use a combination map where we combine field map with symbol map and convey much more information about our chart, about the data, right? We can also use a pie mark type to basically break the data into smaller components and look at the sales or profit per member in that dimension. Like region is the example we took. So we also looked at density maps. One more type of maps that we looked at is density maps, which talks about the concentration of the data, which talks about the concentration, how concentrated or dense or the data is in that particular area. If you have many data points, it will become very dense. The temperature of the map will be high. The heat is high. Also, you can also call it a heat map or temperature map or density map. Now we will proceed further and look at map layers, data layers, and other concepts that are there in this module. Okay. So when we create a map, whenever we create any map in Tableau, let's say I'm bringing country to detail to show the data for the countries present in Superstore, and state to detail. So now it will show me the states. Now here you will notice that Tableau is not just showing you data points like that. It is showing us some extra information. Like you can see that it is showing you the country border. It is showing the state borders. It is showing you the names of the name of the country here. It is showing you the names of all the states behind, right? So these are called as map layers. This extra information which Tableau is providing to us, they are referred to as map layers. Now, how do we access map layers? Is we go to the map option on the menu, go to map layers from there. Go to map option on the menu and go to map layers from there. When you click on that, the map layers pane will come and it will overlay your data pane. Map layers pane will overlay your data pane. Here there are different styles that are available in the map which you can choose from. The default being light, you can change that to normal. It will be like a light blue kind of thing for water and all. You can change that to dark. Map will become dark and you have the data points on it. You can decide what should be the washout percentage. Washout means you can see the map is getting less and less intense, right? If I use washout as 100%, I have basically completely washed out the map from the canvas. I completely washed out the map from the canvas. So that is washout, okay? Then we have other styles which were introduced in 2019, I think, or 18.3 or something. Streets is one style. Okay, then when you use street as the style, you can see streets and highways is a map layer that is selected by default. But it is not active because at this level of zoom, it is not possible to show streets and highways. It's not possible to show streets and highways, right? Where we are showing the entire data for United States, will it be possible to show streets and highways here? Definitely no. But as you zoom in, let us say I'm going to zoom in here. as I zoom in, if it is possible to show the streets and highways there, it will show you with this red colored line. Okay, streets and highways, it's showing us there. Now, at any point, if you want to reset your map to the original, you will simply click on this pin icon. That will reset your map to back to the original. Then outdoors is another option that we have. And then finally, we have something called as satellite, and satellite views have become very popular. Tableau uses some technology named as vector tiles. VECTOR, vector tiles, TILES. Some technology pertaining to maps, which makes the maps much smoother and sharper. So as you zoom in, okay, let's say I'm zooming in California, you get a very smooth and sharp map. And like this, you can go up to 16 levels of zoom are supported. 16 levels of zoom are supported when you zoom into a map. So that is satellite maps, which came recently, I mean, maybe a year or two ago, and they have become very famous ever since they have arrived. Okay, now let us go back to the light, which is the default style, and explore a little. And I will also reset the map to its original here. So base, land cover, country, region, borders and names, state, province, borders and names are being shown by default. Okay. In addition to that, if you want to show any more layers, you will have to simply select that layer by clicking on it. Like for example, I want to show coastline. So when I select coastline, you see this line running along the coast, which came up. Okay. Then will it be possible to show streets and highways at this level? It's not going to be possible to show streets and highways at this level of zoom. So it is deactive. But suppose you zoom in, and if it is possible to show the streets at that level of zoom, Tableau will allow you. So once you select streets and highways, they are showing up. You see here. But the problem is when you use streets and highways, better to use the map style also, which will support it. So that way what happens is these streets and highways, they will stand out very clearly on the map. Otherwise, they will not stand out very clearly on the map. Okay, it will be like a very light shade of gray, which is similar to these country border, state border gray line. And you will not be able to really, it doesn't come out very clearly. Okay, this is also in gray or deep gray, and then you'll have the streets and highways also in a gray shade. So at that level of zoom, whatever is possible, Tableau will allow it. Like area code boundaries, we can see area code labels, we can see US metro boundaries, we can see US metro labels, we can see water labels, we can see cities, we can see. So whatever Tableau thinks is possible to show at that level of zoom, it will show you. Okay, I'm going to reset the map now. Whatever is not possible, it will go back to being deactive. It will go back to being deactive when you zoom out. All right, very interesting. And now I told that when we are creating a geographical map, it is always good to give the data in a proper hierarchical sequence. If we do not give in a hierarchical sequence, there is a chance that we will run into ambiguity issues. What does it mean when I say something is ambiguous? Multiple places. Like if a city's name is ambiguous, that city is probably present in multiple states, right? For example, or county you take, Washington County is present in multiple states in US. District of Columbia has a Washington County, Indiana, North Carolina, Oklahoma, okay? Or you take Jefferson. So many different places. So all these counties named after the presidents of United States, multiple are there. Like we have in India, right? We have MG Road, SD Road, all those things. So when you are dealing with something at a lower level of detail in a geographical hierarchy, right? When you're dealing with something at a very lower level of detail in a geographical hierarchy, lower level of detail means what? Like counties, cities, okay, congressional districts, because city is something that belongs to a state. State is something which would belong to a country. Country is something that belongs to a continent or a region. So we have to provide the information in a proper hierarchical sequence, which is a good practice. So these are the map layers that you can add. In addition to map layers, we can add something called as a data layer also. Data layer is specific only to United States. There are no data layers for anything other than United States. And when you use a data layer, it basically comes like a background color. Like for example, suppose I want to show the population statistics of United States of America over here. You see how the background is getting shaded with the color? Okay, indicating the population data. Now suppose instead of population, I go and show per capita income. It will get replaced. Population will get replaced with per capita income, because at any given point of time, we can show only one data layer. Only one data layer. We cannot show multiple data layers. Okay, so you can have multiple map layers, but you can have only one data layer. That is a point to note here. And data layer is specific only to United States and not to any other country in the world. It is not available for any other country in the world. That is another point. After you have put all the layers necessary, you can simply close it. It will be gone. I mean, you can close it and return to the data pane. That now, let us say I want to see sales. I can put that on the size shelf. Okay. So whatever map you have created, if you want to enhance it by adding additional layers to it, then you can always use map layers and data layers to enhance it. Try it out, map layers and data layers, for a minute. Then I will take you to the next concept, which is how do we edit an unrecognized location in Tableau. Yeah, now you go ahead and practice map layers. I've given you time to practice map layers and data layers. Once you do that, we will proceed to the next concept. Okay. And I got connected to Global Superstore for the next example. So you can also get connected to Global Superstore for the next example. So I hope map layers, data layers is clear. We'll proceed to the next concept, which is about editing an unrecognized location. Okay. Now, as long as we bring the data in a proper hierarchical sequence, Tableau will be able to plot them on the map without any difficulty as such. Suppose you skip the hierarchy, that is where the first problem comes. Like for example, in this example, what I will do is, let's say I'm connected to Global Superstore, and let's say I'll bring city to the retail shelf. All right, I'm connected to Global Superstore and I brought city to the retail shelf. Now, when I bring city to the retail shelf, what will happen? I have not given the name of the state to which the cities belong, and I have not even given the name of the country to which the state belongs. No country and state information. Okay. I'll give you that link. Actually, data sets are there in AI Spry. One or two things which I do, slightly differently, they are not there. Okay, that is where you'll find all the data sets. Another place where you can find all the data sets. All right, so coming here. Now what I did is I directly brought city to the detail shelf. I brought city to the detail shelf. So I have skipped 2 levels of hierarchy here. I did not tell Tableau the state to which the city belongs. I did not tell Tableau about the country also. Country and city, both levels I have skipped. Now when I do that, Tableau managed to plot whatever cities it recognizes in India for me. Whatever it recognizes in India, it has plotted. And other cities, it is giving me a message where on the bottom left corner of my canvas of that window, of that view pane where we are seeing the map, it is giving error, grade, something 4K unknown. Okay, when I click on that, so whenever you create a map, if there is any location which Tableau is not able to plot on the map, okay, for whatever reason it is not able to plot, it will give you the message on the bottom left right corner, sorry, on the bottom right corner of the canvas. Left right, still I get confused sometimes. Okay, bottom right corner of your screen, something unknown. When you see some number followed by unknown, that is when you get to know that okay, Tableau could not plot all the locations. There is some problem here. There are certain locations which it is not able to recognize probably. Let's go and check the reason. So when you click on that and say edit locations, you may get a different map. You may or may not get India. Okay, depends on what is your system local and default location. So you can see for me, default country is India. So from the data points that are available for India, whatever it was able to recognize in India, it plotted them. And for the rest of the world, it could not plot because Tableau is trying to look at search for those cities in India. Okay, so everything else unrecognized or some of them ambiguous also. So what does it mean if Aurangabad is ambiguous? Aurangabad is present in Maharashtra and it is also present in Bihar. Aurangabad is a city that is present in two different states in India, so it could not plot Aurangabad. Then if you take Fatehpur, present in Uttar Pradesh, Rajasthan and in Haryana. So Tableau could not plot Fatehpur. Getting it? Ambiguity. We did not tell in which state it is supposed to plot. Therefore, ambiguity. Now, when I edit the locations, you see Aurangabad ambiguous, Fatehpur ambiguous, Gorakhpur ambiguous. All these are places which Tableau is not able to plot because they are in multiple states in India. Then rest of the cities not even recognized at all. Other cities, at least it is telling that I'm confused, there is ambiguity. And rest of the cities, it is directly telling I don't recognize them at all. Why? Because these cities are not present in India. And remember, Tableau is trying to search for these cities in India now. That is why the problem arose. How do you fix it? Is first of all, bring the data in a hierarchical sequence. Means here I will tell Tableau to take the information about the country, not from a fixed country, but from the field which is named as country. From the field which is named as country. Okay. Now, when I provide this information, it is able to plot most of the cities. You see how the number of issues is now reduced? Only 493 issues. Because all the cities that it recognizes in the respective countries, it has plotted. then there are a few unknown issues. Okay, let's go and check. Now what is the problem? Okay, let's check what is the problem now. Again, ambiguity. Aberdeen, ambiguous. All these cities ambiguous. Now why still ambiguity? Let's see. Aberdeen is present in South Dakota in US. It is present in North Dakota, North Carolina. It is present in Scotland and so many different places, Mississippi, Maryland, so many places. So again, obviously there is confusion. So what do? Provide the name of the state also. Provide the name of the state also. Once you provide the name of the state as well, it will try to plot those cities in the respective states that they belong to. I hope you're getting the point here, that if you do not give the data in a proper hierarchical sequence, you will run into such issues. So give the data in a proper hierarchical sequence. If your map is US, then you change this here. Country, click on country and change that to field country. Maybe it is fixed as United States. You have to change it to country. Okay, Ibrahim, you have to do this. Now, still there are some issues. Even after giving everything in a proper hierarchical sequence, even now there are certain issues. Now, how do we fix them? That is something we need to learn. Okay, as long as we give it in a hierarchical sequence, there will not be any problem. Sometimes even when you give in a hierarchical sequence, if you do encounter some problems like this, then what do we do? How do we go about it? Is you can go to each member which Tableau does not recognize and start typing in a matching location. There is a chance that you will find a matching location. If it is there in Tableau's repository, we'll find it. So if a matching location is found, you just click and select the matching location. Issues will start getting fixed. Okay, so you can see the number of issues getting reduced. Now let us say you started typing in a matching location and you could not find anything. When you start typing in a matching location, let's say Tableau does not recognize that place at all. Let's say information for that place is not there in Tableau's geocoding data. Then what do? Then we go down to the lowest level of detail. What is each and every data point on this map representing? Can you tell me? What are the data points on this map representing? Cities, right? They are representing cities, not state, not country. They are representing cities present in some state which is in some country, but ultimately the data point itself is representing a city. So we go to city level of detail, and here you can start typing in a matching location. Or let's say when you start typing in a matching location, you did not find anything. In that case, what you can do is you can manually choose to enter the latitude and longitude. So when you click on enter latitude and longitude, this pop-up will come where we can enter the latitude, which should contain at least 1 decimal place, and we can enter the longitude also, which should again contain at least 1 decimal place. Okay, so that is how you fix, by providing manually the latitudes and the longitudes. Now I'll give you an example of my own here, because I need you all to give me 100% of your attention. We are going to discuss a concept called as custom geocoding. Entering the latitude manually is fine, but how do I make it more like a permanent fix? Then I will have to go with custom geocoding. Okay, now you have been given Australia file for your practice. You have been given this file for your practice, so you can connect to the file and practice. I will be using a different file to explain the concept in the class. Okay, So let's say I have data for the state of Maharashtra, which is a very famous, well-known state from India, present in India. And the requirement is to plot certain cities in this state on a geographical map. Plot the cities present in the state of Maharashtra in India on a geographical map. So how will we do it? I'll take country to detailed shelf in a proper hierarchical sequence. So Tableau will give me India. Now when I take state to the detailed shelf, Tableau will give me, ideally it is supposed to show me a data point for the state Maharashtra, which it is not doing in this case. Instead it is throwing or giving me a warning. As you can see on the bottom right corner of my screen, one unknown. And when I go and check what is the problem, very strangely it is telling me that I do not recognize the state of Maharashtra, unrecognized. So what will I do? I will start typing in a matching location. When I start typing in a matching location, I found it. Okay, I found Maharashtra. So what was the problem? Why did Tableau tell me that it could not recognize Maharashtra, which is there in my database? Spelling mistake. In my database, Maharashtra is saved with this spelling, but in Tableau's geocoding data in Tableau's repository, Tableau recognizes it with this spelling. So because the spellings did not match, Tableau gave me that problem. Okay, now that I told Tableau, okay, this is what I mean when I say Maharashtra, Tableau will be able to show me Maharashtra. Next is I have to plot the cities. So when I bring city to detail shelf, it will plot all the cities that it recognizes. Here, when I worked on this project or on this requirement, Nanded was not recognized. Nanded was not recognized. Then later it got introduced into Tableau's repository. So we used to get the problem of two unknown at that time. Two unknown used to be there. Now with the latest versions, it recognizes Nanded. Only one city it is not able to recognize. The name of that city is Buldana. This also is a spelling mistake actually. If you see, you will be able to find Buldana. Okay, for now, let me say I do not have Buldana here. So I chose to enter the latitude and longitude manually. Let us say I could not find Buldana. So I have decided to enter the latitude and the longitude manually. Now, what do? I will go to Google and I will search for the latitude and longitude for the city Buldana that is present in Maharashtra. So when I do a Google search, I get the latitude and the longitude. Now, which one is latitude? Which one is longitude here? North, degree north, latitude. It's saying it is in the northern hemisphere. Degree east, it is telling it is in the eastern hemisphere. Okay. So this is the latitude and this is the longitude. So Tableau does not recognize north and east. Okay. It will go by the sign. If you're giving a positive latitude, it will plot it in the northern hemisphere. If you're giving a negative latitude, it will plot it in the southern hemisphere. So you have to put the sign. If it is positive, it's not necessary anyway. So this is the latitude information. And this is the longitude information. When I give the latitude and the longitude information manually, you will notice that it will go ahead and plot the city of Buldana on the map over here. Based on the latitude and longitude I gave, it is able to plot it here. So this is more like a temporary fix. This is more like not an efficient way of doing it. Okay, because when I provide the latitude and longitude manually, what happens is that fix happens only in that workbook and specifically only in that data connection in that workbook. Okay, so the fix is more like local only to the workbook where you have provided the details and specifically only to the data connection inside that workbook. Okay, like for example, if I get connected to another data source in the same workbook which contains the same data, only thing is here the spelling of Maharashtra is fixed in the database. Okay, I will again I have same information, country, same state Maharashtra, and the same set of cities I'm supposed to plot in Maharashtra. So when I bring the data to the detail shelf, again Tableau is telling one unknown. Again, when I go and check what is that one unknown, it is telling me I do not recognize Buldana. Why? Just now in worksheet 4, I told you what is the latitude and longitude for Buldana. You were able to plot it, Tableau. And now Tableau is saying, I do not know Buldana. I cannot recognize it anymore. Getting it? So that kind of a fix that you make is local only to the work, to that data connection and in that workbook. In the same workbook, if you have another data connection with the same set of data, again, same problem. Or if you get connected to that data source in a new workbook, still same problem. So how do I make it more like a permanent fix now? How do I fix this thing properly? That becomes a concern. Okay, how do I fix this thing properly? Now to fix this thing properly, what we do is we use a concept called as custom geocoding. We use a concept called as custom geocoding. What is custom geocoding? It is a means by which we will bring the latitude and longitude coordinates of those locations which Tableau does not recognize into Tableau's repository. Okay, custom geocoding is a process by which we bring the latitudes and the longitudes for the places which Tableau does not automatically recognize into Tableau's repository. So how do we do this? How do we do custom geocoding? For performing custom geocoding, step 1 is you have to create a file which should be a CSV file with all the locations which Tableau is not able to recognize, their latitudes, their longitudes, and their parent information as well. And their parent information also. So for custom geocoding, what is it that we need to do? For custom geocoding, step 1 is you will create a .csv file with what information? Names of the locations, names of the locations which you want to introduce into Tableau's repository. Okay. And will the name alone be sufficient? Name alone won't be sufficient. You have to tell what is the latitude of that place and the longitude of that place. In addition to this, you also need to give the parent information if applicable. What does it mean, parent information if applicable? For city, what will be parent? State, and further country. If you're trying to introduce the data for different states, then you should also give the name of the country. If you're introducing the names of the countries into Tableau's repository, that is the highest level, no? We don't have to give anything else. So depending on what you're putting into Tableau's repository, you should also give the parent information wherever it is applicable. Okay, then after you have created this file, you have to save it in a folder. Save it in a folder or whatever you or directly, whatever it is called. After that, step 2, we'll do step 1. Step 1 is you create a CSV file which will contain the names of all the places which you're trying to introduce into Tableau's repository. So I'm trying to introduce certain cities here. All those, here I have only one city though. You can put as many cities as you want. Here Buldana, latitude, longitude, and the parent information. After you create this file, what will you do? You will save it in a folder. You will save it in a folder. After you save it in a folder, you will have to do step 2, which is import the folder with geocoding data. So basically you're going to import geocoding. I'm specifically saying folder here. So what we'll do how to import is we go to map option. There you will find geocoding, which is not available on Tableau public. If you're working on Tableau public, you will not find the geocoding folder. Okay. And then you will select the option to import custom geocoding. Select the option to import custom geocoding. So what I'll do is go there, go to map, geocoding, and import custom geocoding. Then I will have to click on these three dots and select the folder where the CSV file is present. Do not double click and go inside the folder. No, just one click, select the folder and hit select folder. After this, we will hit the import button and the import should happen. Let's see, some on this new version, I think it's failing. There's some bug here. 2020.2 geocoding is not happening. So I'll show it to you on 2020.1. Maybe they fixed it in 2020.3. It's going to come out. We'll see. So give me a moment. Very quickly, I will redo this. Just give me 1 minute. I'll replicate that example. And it's taking a lot of time today. System is a little slow. So it's importing the custom geocoding. Meanwhile, we will discuss about a few important points. So fine, how to custom geocode the data we understood, and how to import that data into Tableau's repository we have understood. Now let us see what will happen. Let us see, where does Tableau store the custom geocoding data? Okay, so when you import custom geocoding in Tableau, Tableau stores the custom geocoding data in a folder called as local data or geocoding data. Now the latest version, it is renamed as geocoding data, present in your Tableau repository folder, in your documents folder. So whenever we download and install, Tableau on our machine, what happens in the documents folder, we get a folder named as My Tableau repository. In that My Tableau repository, there is a folder called as local data or geocoding data. Right now, the name is local data import because import is happening. Import is in progress right now. Okay, once the import is complete and successful, this folder will actually disappear. It is kind of a hidden folder and it will disappear. It will be renamed to geocoding data and then it will go away. So this is where your custom geocoding data will get saved when you perform geocoding. That is the first point to remember. Next point is, where does Tableau, what happens to the geocoding data when I save my workbook? So when you save your workbook as a packaged workbook, now where is this custom geocoding data getting saved? It is getting saved on our local machine where we have Tableau installed. In the Tableau repository folder only it's getting saved, which means when you do custom geocoding and the data is getting saved locally on your machine, that data becomes a local resource, right? See, import is done, import is over. So you see the name of the folder changed to geocoding. Now, so when you save it on your local machine and it has become a local resource, what does it mean? If you save it as a packaged workbook, if you save your workbook as a packaged workbook, then that geocoding data, which is a local resource, will get packaged internally in the workbook itself. Because we know the property of a packaged workbook. What is it? It will package all the local resources inside itself only. That is why even geocoding data gets packaged internally in the workbook. You see, once geocoding is complete, the globe icon against city is slightly different because we have done geocoding and imported the name of the location. And you can see Tableau automatically plotted Buldana here. All right, so that is how custom geocoding is performed. And that is how we can make it more kind of a permanent fix by doing custom geocoding, and the latitudes and longitudes for the places which Tableau does not recognize will go into Tableau's repository. And when if you have done custom geocoding, make it a point to always save the workbook where you have done custom geocoding as a packaged workbook. If you save it as a normal workbook, then this information will not be packaged, and if this information is not packaged, the client will not be able to access the geocoding data. That would be a problem. Okay, so whenever you do custom geocoding, it is a good practice to save your workbook as a packaged workbook. No, this will be applied to all the other workbooks that you are going to open and create subsequent after that. See, where is it getting saved? It's getting saved in your repository. So going forward, whichever workbooks you open and work with, this geocoding data is going to be available to you until and unless you go and remove the geocoding. If you go and remove the geocoding only, it will be gone. Otherwise, it is available to you on your machine. Okay. So that is about custom geocoding. And there was a webinar that was conducted on custom geocoding. Just 2 months ago, I think we conducted the webinar where you can actually check additional examples on geocoding. Okay, if you want any additional examples on geocoding, there was a webinar conducted, you can check there. Then, next concept is, just give me one moment, I'm going to pause screen share. One second, huh? I am just searching for that. Or maybe it will be in your repository, right? In your AI Sprite, do you have a folder with all the geocoding? Not geocoding. Do you have an access to the webinars that are being conducted? in your folder? In your AI Sprite, do you have any folder with all the webinars? No? Okay, maybe because all the webinars are being made YouTube live, so they are not giving. They're not giving it over there. Then I'll do one thing. Today I will search for the link and tomorrow I'll share the link with you all, okay? Currently, they have not segregated it into categories. And we are not able to find it here. I think I will search for it and I will provide it to you. So there is this webinar on custom charts, which you can go through after we complete custom charts. Okay, some additional charts are covered here apart from what we do in our regular training. Mostly on data science only we are. Data blending is something that you all know. We don't need that. Basic charts in Tableau, you all know. You don't need that. Context filters we discussed, I think. So yeah, okay. Anyway, I'll search here and I will give you all the link so you can. Okay, let's proceed with our training itself. So that video on data on custom geocoding in Tableau, I will check for it and provide it to you. There are some additional examples. That's why I was thinking it will be good for you to go through anyway. Okay. So the next concept we are going to discuss is how do we create custom territories in Tableau. Okay, how do we create something called any questions on geocoding? Is it clear? You will have to practice this. This is something I request you all to practice using that Australia dataset given to you. And for additional examples, you can refer to the video link which I will share with you tomorrow. But as of now, based on whatever we have discussed so far, is it clear the concept of custom geocoding? When do we do it? When Tableau does not recognize certain locations and you want to fix that problem and you want to make it more like a permanent fix in the sense you want to introduce it into your Tableau repository, then you do custom geocoding. So when you do custom geocoding, the geocoding data is available for you in all the subsequent workbooks also that you will create, that you will open and work on. Okay. Okay, next concept is creating a custom territory in Tableau, which we will do by using these selection tools. Okay, the moment you hover the mouse pointer on a map, you will get the map search icon on the top. Then these are map options. Plus is to zoom in, minus is to zoom out. Okay, and there is a pin icon and there is an arrow mark. When you click on the arrow mark, there are certain things that you can do here, like you can use the selection tools, rectangular selection, radial selection, lasso selection. These are called as rectangular, radial, lasso. Using these selection tools, we can basically select the data points and we can create a region or a territory out of it. We can create a region or a territory out of it. Now, how do we do that? Let us see. So I think you have to do it on the United States map in your assignment. We will do it on Africa map here. Get connected to Global Superstore and use the orders worksheet from Global Superstore for creating the map. Bring country to the detail shelf and you can take state to the detail. No, let's leave it country level. Bring country to the detail shelf. Now what you do is take region to color. So the countries belonging to each region should ideally come up with a different color. Okay. Or you can take market, I think, to the color. Market to color. Okay, now let us focus only on African market. So I'm going to color code convert it into a filled map, and then I will look at only African market. Market to the filter shelf and choose only Africa. And click on OK. All of you please replicate this map. Create a map that will show you the data for Africa. It is not necessary to have market on the color shelf because we are focusing only on one market, not on multiple markets, right? So we will remove that. Okay, now my requirement is I would like to select a few countries present in Africa and create a region or a territory out of it. Okay, so I have decided to use the selection tools. I'm using rectangular selection tool, as you can see on my screen. I'm using rectangular selection tool. After choosing the selection tool, when you do a click and drag on your map, when you do a click and drag, you see all these are selected. So all these states which I had selected using the selection tool are now highlighted on the map. And when you hover the mouse pointer on any one of the section, any place in that selection, when you hover the mouse pointer there, you will get a paperclip icon on the tooltip. When you click on the paperclip icon, Tableau is going to combine them together and create a region out of it. So this is one territory and this is the other territory. Similarly, you can use any selection tool of your choice, whatever is convenient for you, you can use that and create a few territories. So I'm going to select these, maybe till here, and I will again click on the paperclip icon and make this into one more territory. And again, I will use a selection tool, this time lasso. Lasso is like freehand drawing. So I will go over all this I want to select. Okay, and I am going to click on the paperclip icon. That becomes another territory. So I think I will check this one. Okay, everything I have selected. You can also manually click on the data points one by one. You can hold on the control key and select them. That is also fine, whatever is convenient to you. So we have selected everything, and this is basically data split into 3 territories. Now, let's say my requirement is to look at the profits that we have obtained, that Superstore has managed to get in each territory. What is the profit of Superstore in each territory? What is the profit of Superstore in each territory? Now, how do I do that? If I take profit to the label shelf, then each country is getting labeled with the profit. My requirement is not to look at the profit per country. No, I want to look at the profit per territory. What is the overall profit? What is the complete profit in this blue territory? What is the complete profit of red territory? What is the complete profit of orange? I don't want country wise. No, territory wise, I want to look at the profit. So what I will do is I will remove country from the detail shelf. I will remove country. I don't want the granularity at country level. I just want a territory level, which I have already created, the territories. So I will remove it from there. It's computing the layout and it will give me the data rolled up at territory level, the overall profit per territory. It's taking a lot of time. Maybe you can take a, fine, came back. This other I will remove, okay? I think I missed out a few things. So anyway, so you can see how we are getting the profit per territory now. Okay, so this is the advantage. What have we done here? We have combined certain standard geographic locations, which is different countries present in Africa with well-defined boundaries, together and created a region or a territory. Is this concept clear? And we are also looking at the statistical information at territory level rather than going at country or state level. Any questions on whatever we have discussed so far today? Are you all able to do this territory thing? If you're getting other, just exclude other, okay? You right click on other and exclude it. All right, let's take a break for 10 minutes here. After the break, we will continue. Okay, we have to do another concept called as polygon maps and a few more things from this module. So I'll see you after 10 minutes. Thank you.
This conference will now be recorded.
So we have discussed the concept of creating a custom territory in Tableau, and we have seen how to create a custom territory. Okay, it is basically a combination of certain standard geographic areas. Combine some standard geographic areas with well-defined boundaries and create a region or a territory out of it. Okay, now what if the region or territory that you're trying to create is not a combination of any standard geographic locations? What if it is just something very random? Okay, what if I just have to randomly come up with one territory like that, randomly with one territory like that, randomly with one territory like that, randomly with one territory like that? This is not a combination of any states. It is not a combination of any cities. It is not a combination of anything for that matter. Just a few random territories that I'm trying to create. Okay, then how do I create it? So to come up with geographic areas or territories which are not standard, then we will use the concept of polygon maps. Polygon maps. Okay, so every non-standard geographic area that you want to create is called as a polygon, and that polygon will be given a number called as the polygon ID with which it is recognized. Now few points to remember here is polygon maps cannot be created with the latitude and longitude generated fields coming from Tableau's repository of geocoding. No. To create polygon maps, latitude and longitude information should be present in your database. So that becomes a required field. What is the field that is necessary to create a polygon map? Latitude, longitude, and every polygon that you want to come up with is called as a polygon, has an ID called as polygon ID. Okay, this is all mandatory data to create a polygon map. Then when I take the latitude and longitude that is there in my database, and if I plot it on the map, let us say the first combination of latitude, longitude is this. Then latitude, longitude, latitude, longitude, latitude, longitude. So every latitude and longitude combination is going to be a point on the earth, right? A unique location on the earth. So within polygon 1, Tableau will plot all the latitudes and longitudes. Then every dot, every point, which is the result of the combination of latitude and longitude, will have an ID associated with it called as the point ID. So that point has an ID called as a point ID or point number, or anything you can call it. Okay, point ID, point number, point order, something like that. This will tell Tableau about the sequence in which these dots are to be joined together, the sequence in which the dots have to be joined together to complete the polygon. Okay, so I cannot say randomly I will go like this, and that should be a polygon. No, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6, 7, so on in a strictly sequential fashion till it comes to the last point ID, last point order. How does it know it has come to the last point order? When it does not find the next number in the sequence, because point ID is strictly sequential. So that is when it connects back to 1, completes the enclosure, and Tableau will lift the pen. Then it will see, is there a polygon 2? Yes. So for this polygon 2, these are the combinations of latitudes and longitudes, dots. Now Tableau will go and place the mouse pointer with near that dot which point ID 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, like that. Let us say about 3000. After 3000, when it does not find the next number in the sequence, which means what? It has completed the polygon. It connects back to 1, finishes the enclosure and completes the polygon. Polygon 2 done. Then it will see, is there a polygon 3? If there is a polygon 3, where is the point associated with point ID 1? Put down the pen there. 1, 2, 3, 4. Complete the enclosure. Go to polygon 4. So just imagine this to be like join the dots game, which children play, right? When they are being taught numbers, usually kindergarten children, they are given these figures with numbers and dots. So they have to just join the dots in the sequence, and that whatever that figure will come out. It could be an animal or a tree or a plant or a flower, something like that. So that is exactly what is happening with polygon maps. So what is the necessary data to create a polygon map? The data that is necessary is you need to have latitude and longitude in your database. You need to know the polygon ID, latitude and longitude associated with the polygon, and every latitude longitude combination which is going to be a point, that will have an ID called as point ID or point order or point number, telling Tableau about the sequence in which the dots are to be joined together. Okay, now in your database there is one data source called as, in your ASPI data sources that you have downloaded, there is one data source called as national polygon data. I think you can get connected to that. Get connected to polygon data source, and then we will see how to create a polygon map. National Parks Polygon, I think, is the name of the data source. National Parks Polygon data. Connect to it. There's only one worksheet in it, so you can just directly connect to it. So you can see latitude and longitude is present in the database. Polygon ID is there. Point ID is there. With all this information, we just have to go and create the map now. You can double click on latitude and double click on longitude. After you connect, double click on latitude, double click on longitude, or drag and drop latitude on the row shelf, drag and drop longitude on the column shelf. What Tableau will do is, it will aggregate them. Just like it aggregates the measures, it is aggregating latitude and longitude also. It's computing the average of the data in the latitude column. It is computing the average of the data in the longitude column. So average of all the latitudes is 53.03. Average of all the longitudes is minus 2.273. All right, when Tableau computed the average, it came up to be this point here in UK, based on the average of the latitudes and average of the longitudes. But we want this for all the polygons. We want to see all the polygons, right? So we will bring polygon ID to the detail shelf. When I take polygon ID to the detail shelf, Tableau is now granularizing the data. What is it doing? It is computing the average of the latitudes and longitudes for different polygons. Polygon 15, average of latitude and longitude. Polygon 3, what is 2? What is the average of all the latitudes and longitudes? It is showing us a data point. But is this what we are trying to do? What is this map? What would you call this map? We would call this a symbol map, right? It is a symbol map because we are representing the data as a symbol. It's a symbol map. We don't want a symbol map. We want a polygon map. Now, how do we tell Tableau that we want a polygon map? We change the mark type to polygon. Okay, all of you please do this. Change the mark type to polygon. It'll go a little weird, but don't worry. A shelf called as path shelf has come up. Right? We told Tableau that we are trying to create a polygon map, and the moment I do that, a shelf called as path shelf has come up. path shelf will tell Tableau about the sequence in which the dots are to be joined. Sequence. Okay. So I will take point ID, which basically has the numbers for every point there, the sequence in which the points have to be joined. Take that to the path shelf. Now it will be able to connect the dots properly and also complete the enclosure for us, and polygons are ready. Okay, you can also take polygon ID to color shelf. You can get polygons in different colors. Okay, all the information is right here on the screen on how to create a polygon map. Please replicate it and let me know if you have any questions on this concept. Thank you. Do it, then we'll proceed next. Okay.
For me, the map is not coming. The dots are only coming.
Okay. Background map is not coming at all.
No, only the dots are coming.
Okay. Can you check on your map? What is it selected here? What map is selected here? Light should be selected. Ibrahim. Data set will be in your AI Sprite data sources folder. Yeah? When you download it, no? Or even the link I shared with you all, no? Google Drive link today also I shared with you all. What happened? Sai, Rani. I shared the drive link. Yeah, tell me.
Yeah, I'm looking at the CSV, National Parks Polygon, National Parks Polygon. I have attached it as a CSV. Once the file has been attached, I got park ID, park name, point ID, polygon ID. When I'm putting polygon ID in the details, I'm just getting dots over here.
Dots only you'll get. Did you change the mark type to polygon?
Automatic to yes.
Now you get the path shelf.
I'm still in. No.
Okay, let me make you the present. No, 1 minute. Let me make you the present.
I think I'm doing something wrong there.
Latitude, longitude in the correct place. If you have interchanged this, then also it will not come. Latitude, longitude, if it is in the wrong place, you will not get.
Latitude is in the columns, longitude is in the rows.
Then swap.
And
no, then you have to swap. Swap.
Swap it, is it? Okay.
Then you should be able to get it.
Yeah, it's come. It's come. Thank you.
Okay. So Rani and Vivek, did you get the data set or do you need the data set? Downloading it now. Okay, Rani. What about you, Vivek? Did you download it? Vivek, are you able to download the data set? Oh, all right, great. Okay, fine. So do it. I'll give you all a minute here. All right, I hope all of you are able to create polygon map, or you can just take a screenshot here if you want to. So you can notice that polygon ID is on detail shelf, point ID on path shelf, mark type is polygon, longitude on columns, latitude on rows. Okay, if you are not able to do it right away, you can take a screenshot here, and later on you can practice it. So we'll go ahead, we'll proceed to the next concept, or one extra concept I want to cover here from my side. So when we say polygon map, so much data is actually internally stored, right? Yes, yes, it is compulsory every time that longitude should be on the column shelf. Longitude should be on the column shelf. No, it is longitude, no? It goes from north to south. So it has to be on the column shelf. Latitude is this horizontal, no? So it has to be on the row shelf, right? Okay. Now there are some special type of data sources, files called as spatial files. This data set is not given to you. This is something I'm doing from my side. There are some special files called as spatial files. Okay, they usually have the extension, we'll see, spatial files, which contain a field called as geometry. There are some special files called as spatial files when we are performing geospatial analysis or geographical data like this. Okay, spatial files. What do spatial files have is they have a field called as geometry, and this field geometry has all the information to create maps like this. Non-standard geographic areas. There are three types of geometries which Tableau recognizes: point geometry, line or line string geometry, and polygon or area geometry. Polygon means it's like an area, no? Geometry. So what will geometry have is, it will have all the data that is necessary to create this type of maps. Suppose you want to create a polygon map, then geometry internally in that word, in that field, it has all the information to create a polygon. Or if it is a line, then it has all the information to draw a line. If it is a point, it has all the information to put the point. These are special files. Okay, well, geometry contains the information. So I'll just show you one spatial file connection. How do we connect this? We have to choose spatial file. After choosing spatial file, I will just navigate to the place where I have it. So this is Brimbank Road Network spatial file, which has the extension .shp. Tableau also recognizes other extensions, as you can see here. Okay, .shp, Brimbank Road Network. When I get connected to that file, okay, there is geometry. What is the geometry? Line string, which means the data on the map will come in the form of lines, not area, but lines. So the geometry is line string. Now I'll reach the canvas and I will take geometry to the detail shelf. When I take geometry to the detail shelf, all the collection of all the lines, it is showing me as one big block of data. As one big block of data. Why? Because geometry is aggregated using collect as the aggregation. It is a collection of geometries. It is a collection of lines in this case. Now Tableau can work independently, separately with point, line and area geometries. It cannot work with the combination of all the three geometries in a single file. Okay, so if ever you have to connect to a spatial file and perform geospatial analysis, you will have to choose spatial file option, navigate to the place where that spatial file is there and select it. After you select it, data comes up and you take geometry to the detail shelf. It's a collection of geometry, all the lines collected together. Now you either disaggregate the data, so you can see individual lines, okay, different types of roads over here by disaggregating, or you keep it aggregated like any other measure and you granularize it. Let us say I want to look at the road name type. So you can see different roads coming up in different colors there. So maybe a node name type is too granular. I will take just road name to the color sheet. All right, or road type. This is better. So you can see drive, you can see avenue, you can see corners, you can see different things you can see there. These are all line. This is line geometry. Okay. That is geospatial files. How do you create a map from spatial information? Okay. So now we'll proceed to the next topic that we have in the syllabus. Web map service. Now all the maps that we have been creating so far in Tableau, where do you think these maps are coming from? Right? Now we have created a lot of maps, but where is Tableau getting all of its maps from? Tableau gets all of its maps from these people, OpenStreetMap people. Okay, you can see the copyright symbol on the bottom left corner of the canvas of the view pane of the window. Copyright 2020 Mapbox, copyright OpenStreetMap. So Tableau basically gets all of its maps from the OpenStreetMap contributors. OSM is a foundation, OpenStreetMap. When you click on it, it will take it to it will lead to you to your website. Okay, so OpenStreetMap, they provide maps, map data for thousands. It is basically a community of enthusiast mappers, geoprofessionals, engineers, so on and so forth. Okay, and we are free to use the maps that we get from these people for any purpose, as long as we credit OpenStreetMap and its contributors. OpenStreetMap and its contributors. How do we do that? By putting their copyright. Okay, so by default, all the maps that we are creating or learning how to create in Tableau are coming from OpenStreetMap and its contributors. What if you want to use a different map as a background? Okay, if you want to use a different map as a background, then you can do that by going to map option. From there, you will go to background maps. There's an option called as manage maps. Now it is manage maps. Earlier it used to be map services. So whether you see map services or you see manage maps, it's one and the same. You click on it. When you click on it, you will be able to add maps of your own choice from here. No, both are different. Mapbox is different. OpenStreetMap is different. They have put the copyright of Mapbox is because Tableau is now compatible with Mapbox also. Okay. Now we'll add, and then I will choose WMS servers. That is one option. WMS servers means any website, any map provider who supports web mapping services. WMS stands for web mapping services. Any service provider who supports this, you can use their map here. So like for example, we will use a map from Zepco. Okay, we are using a map from Zepco. They support, if they support, then you will see under their products, you will see. So they support WMS, web mapping, web map service. You go there and then they will give you the links to the maps which we can use. So to access Zepco's WMS, enter the following address in your WMS client. Our WMS client now is Tableau. For a global map, this is the link that they are providing. So I'll take that link. For a map centered on for a view that is centered on North Pole, this one. For a view centered on South Pole, this one. So I will send you the link which we are using for the global map. Okay, I sent it on the chat. Now, once we have the link, what we will do, we'll go here and we will paste that link in this URL box. Once you paste that URL in the URL box and click on OK, the map that you are fetching from Zepco will become your background map here. That will become your background map here. You see? Okay. After this, suppose you now like this map. You like this map and you have used the map, you have created your report and you're happy with this map. You like it and you want to save it for future use. Okay, suppose you want to save it for future use. Then how do we save it for future use? Again, we will go to the same place, map, background maps, manage maps. Click and select the map now. Click on the link. Okay. Now, when you click on the link, there is an option available to export the map. So when we click on export, it will go into the map sources folder present in your My Tableau repository folder. Map sources present in your Tableau repository, and there you can save a copy of the map. It gets saved as a Tableau map source with TMS extension. TMS extension. Okay. Then once you save it, what happens? Next time you open a workbook, you will be able to see that listed out here. Okay. And then when you select it, that whatever map you have selected, from what saved there, that will come as a background. Okay. So that is WMS. Simply, if you want to use a map of your own choice from the internet and represent the data on that map, you have to go to map option, background maps, manage maps, and then you will add from WMS service. Then you can provide the link. After you provide the link, the connection to that server from where the map is to be fetched is established. Once you do that, that map will start appearing as a background map. Now, if you like it so much that you want to save it for future use, again, you can simply select the map by clicking on it and export it. When you export it, it gets saved as a .tms file in your map sources folder under your My Tableau repository folder as a .tms with an extension of .tms. Okay, do this and let me know if you have any questions. Okay, now I will show you one more example, one additional example in this module. How do we get a map from Mapbox tool? Okay, so Mapbox is a separate tool that is used to design maps. Like Tableau is a tool that is used to perform data visualization. Mapbox is a tool that will help you to create and design your own maps. You can actually design your own maps using Mapbox. Okay. So when you go to Mapbox, that is the link, studio.mapbox.com. When you go there, I'm already signed in to Mapbox here. It will take me to my account. You can create an account for free. Okay, I'm signed in, but you can create an account for free with Mapbox, and then you can design your map. Let us say I want a basic map. Okay, so I'm choosing this. Then the map will come. Here you can decide, what should be the color given to different places in that map, like water bodies, they should come in which color, something like that you can do, and you can structure your map. Basically, you can create, design, customize it. Let's say you have designed your map and you're ready with this map. Now you want to use this map in Tableau. The map that you have designed using Mapbox, you would like to use this in Tableau. Then how will you do it? You will use the share option, top right corner. You will notice there's an option called as share. So you'll have to click on share. Then Mapbox will understand that you're trying to use this map. and it will give you this. Okay, share, style, preview, all this. Now what, with whom are we trying to share it? We are trying to share the map that we created over here with some third party. That third party is Tableau. We are trying to share the maps that we have created with some third party, which is Tableau, and the link will come up, which you just have to copy. Okay, after you copy the link in Tableau, what do we do here? They are telling you go to map, background maps. Now it is called as map, manage maps, add map box map. So they're telling us exactly what to do. So we'll go here, we'll go to map, background maps, manage maps, and then add from map box. I'm trying to add something that I'm fetching from map box. So I'll choose map box. Here you have to paste the URL which you have copied from Mapbox, and all the other information will get auto populated when you click on that. You can give it a name and then click OK. So this new map which I have fetched from the Mapbox, which I have given the name as basic, has now become my background map. You see, that has become my background map. Okay, so Tableau is compatible with OSM, OpenStreetMap, and also with Mapbox. And not just this, you can also get any other maps from people who support WMS. Okay, so that is Mapbox. Now we are left out with one last concept from this module, which is called as background images. I will show you ultimately what we have to achieve. Background image is a very interesting concept that will help you to add more context to your data. It will help you add context to your data by representing your data on a custom background image. By representing your data on a custom background image. Now this data source, injury data, it is called as, and the image, body outline background image. Both of them are available. They are given to you in your AI Spry datasets folder. Two datasets folder will be there. I think module 1 or 2 you'll find them. These are there. So when you have, I think you have already downloaded. You just have to check for these data sources. Okay, and then we will be doing this example tomorrow. So tomorrow, little homework for you. Today after the session, you can spend 5 minutes here. Go through this presentation for background images. How you connect to the data. It could be a text file or a Excel, whatever. What is the data present here is the information for different injured body parts and the date and time when the injury has occurred, data collected from a multi-speciality hospital. Now, we have been given a requirement where we have to represent this data on a custom background image, body outline background image. And to do that, first of all, we have to link the image with the data source. To link that image with the data source, we need to have two measures. Okay, like latitude and longitude are acting as those measures which are triggering or invoking a background image, which is a geographical map for us, right? What is happening when you double click on latitude and longitude? Immediately they are pulling something on the canvas. They are showing us something on the canvas. They are triggering a background image. That background image is nothing but a geographical map, because this map is associated with the geographic latitude longitude fields. Similarly, we need to have two fields which will act as triggers, which will invoke the geographical map for us, which will invoke the background image for us. Like these are invoking geographical map, they should invoke the image. Okay, so ready-made in our data set, we will not get X and Y, which will invoke the image. We have to create them. Therefore, we will use the process of use the method of creating a calculated field. On the analysis menu, you have to go and select the option to create a calculated field. You will need two calculated fields. One field which will hold the width of the image. The width of the image given to you is 99 pixels, body outline image, and height is 325. So after you created the calculated fields X and Y, holding the width and the height of the image. Now, why should this contain the width of the image X? X is supposed to contain the width of the image because ultimately it will form the x-axis. Y is supposed to contain the height of the image because ultimately it will form the y-axis. Okay, that is the reason why we use width for X and we use height for Y. Then we have to link the image with the data source. How do you link? You go to map option, background images, and there you will select the data source with which you want to link the image, where you have already created your calculated fields X and Y. Okay, then you will do the you will add the image. Click on add image button. You will get this dialog box called as add background image. There you have to click on the browse button, navigate to the place where the image is saved on your machine, select the image and click OK. Once you have selected the image, Tableau will show you a preview of the image, and it will also give a name to that image. Automatically, it will also give a name to that image. Then comes the part where we have to do the mapping. X field is to be mapped with that measure that is going to form the X axis and thereby hold the X coordinates for all the data points to be represented on that image. Y field to be mapped with Y measure, which holds the height of the image, which is going to form the Y axis, and later on will be updated to hold the Y coordinates for the data points to be represented on the image. Okay, very important. After that comes setting up the dimensions of the image. So left, wherever you think the image is supposed to start, 0 in this case. Right, overall width of the image, 99. Bottom, where the image is supposed to begin at the bottom, 0. And top, the height of the image. So we are setting up the dimensions of the image. After setting up the dimensions, we go to the options tab. So all this setting you will do on the image tab. Then you go to the options tab. In the options tab, what you will do, you will notice that log aspect ratio is always selected, because aspect ratio is the height is to width ratio of the image. Aspect ratio is the height is to width ratio of the image, which is always selected by default, which means what? It doesn't matter on which device you open the image. You're opening it on a mobile phone, very small screen, or you're opening it on a tab or a laptop browser, desktop browser, or you project it onto a wall. It doesn't matter. The height is to width ratio of the image will always be maintained, which means the image will not get distorted. It will not get distorted. Then sometimes, depending on the data that we are trying to show, there is a chance for the image to get truncated. Image can go, it gets cut into half, or you're seeing only 1/4 the image, you're seeing only 1/3 of the image, so it gets truncated. To avoid image truncation, we select the option to always show the entire image. Okay, after this is done, now we start building the view. Where should we take X? What is X supposed to become? X is supposed to become the x-axis, so it should go on the columns shelf. What is Y supposed to become? It is supposed to become the y-axis, so we take it to the rows shelf. Shall we do it till here? All of you, please get connected to the data source. I think we'll do it today only. Get connected to the data source, all of you. Injury data. Let's do it till here. So we go to connect to a new data source icon. Choose the file. I have an Excel injury data. Even if you have CSV file, that is okay. Click on open. You will see that this data set contains two columns, injured body part and injury date and time. Data collected from a physiotherapist's office. Now they want us to represent this data on a body outline background image so that it adds more context to the data. Ultimately, what I need to represent is the injured body parts and the number of injuries that have occurred on each body part. Just need the count of the number of injuries that have occurred on each body part. We can give it this also. This is also telling the same thing. Abdomen, 6 injuries. There are patients, 6 patients we got with injuries to the abdomen. Arm, 6 injuries. Back, 23 injuries, so on and so forth. More than sufficient. However, when you represent it on a body outline background image, it becomes more contextual. So to add that context to the data, to clearly tell the client that we are talking about injuries that have occurred on various body parts, we have decided to represent this data on a body outline background image. So what do we do? First, We need to have those measures which will trigger and bring the image onto the canvas. We don't have the measures in our data source. So what we will do, we will create them. Now you have an assignment to solve on the same concept. Okay, please listen all of you. You have an assignment to solve on the same concept. But in your assignment, X and Y are already present in the data source. You don't have to create a calculated field. You don't have to create a calculated field in your assignment because X and Y we have already provided to you as columns in that Excel sheet. So directly you will go and manipulate and edit the data over there. In this example, we don't have X and Y directly, so we are going to create the calculated fields. Analysis, create a calculated field. You can give it any name. I'm calling it X, so it is easy for me to understand. I'm talking about X data points. Initially, it should hold the width of the image, which is 99 pixels. Now, how do you know width of the image is 99 pixels? When you check the image that is given to you, body outline image, when you go to the properties of that image, you can see what is the width of the image and what is the height of the image. When you go to the properties of any image for that matter, when you right click on go to properties, you can see the width and the height. That is what I'm using. Okay. So create your X with 99 and click on OK. Then you create another calculated field with named Y and give the height of the image there. Okay, that is Y. Create it all of you. Once X and Y are ready, once X and Y are ready, what we will do? Now we will link the image with the data source. So how do you link the image with the data source? We will go to background image option on the map menu. Select the data source with which you are trying to link the image. The data source with which we are trying to link the image is injury data. Select it. Now click on add image, browse and go to the folder and go to that image and select that image. Click open. Select the image and click open. Okay, once you select the image and click OK, you should be able to get a preview of the image here, and you can notice Tableau is also giving a name to that image. Okay, after this mapping X to X, Y to Y, left 0, I want the image to start at 0 and I want it to extend up to the entire width of the image, 99 pixels. At bottom it starts at 0, top it is 325 pixels. Then after you do this setting, you go to options tab and select the option to always show the entire image and click OK. You have to make sure that you have X and Y, X and X, Y and Y, Y and X, nothing will work. X and Y. Okay. Now you take X to the columns shelf and you take Y rows shelf. What was it? My expectation was that, like when I bring latitude and longitude, I got a map. Similarly, when I bring X and Y, I will get an image. That is what I thought and began this whole exercise. Why do you think it's not coming? Because When you create a calculated field with a constant value in it, that value will get repeated across all the records. So Tableau is doing summation of all the 99s and summation of all the 325s, giving you summation of all the entire data in X to be 99,899, 19,899. Summation of the entire data in the Y field, so and so. So with such big value, image is probably shrunk like a dot over here. Okay. So what we will do is we will lower the aggregation. You can make it average. Average of all the 99s is 99 in that column and 325. So given 99 and 325, the image will show up. You can change the fit to entire view. Okay, please, all of you do it till here and let me know if anybody is not able to trigger and bring the image onto the canvas. I'll give you all a minute here. Okay, Rani, thank you for the confirmation. Anybody else? Fit as you just change standard to entire view. Standard to entire view. How to insert the image? You go to map option, go to background images, select the data source, and then you click on add image, browse, select the image, open, and then set the dimensions. X to X, 0 and 99, Y to Y, 0 and 325. Go to options and always show entire image option has to be selected. Okay, Suresh? Ganesh, you're not getting the image. So if I make you the presenter, will you be able to share your screen? Okay. Ganesh, can you share your screen if I make you the presenter? Okay, let me make you presenter and check. And tomorrow morning, we have a session on Tableau online. Anybody who is free and can attend, you might want to attend it, okay? Morning 7 o'clock. Topic is Tableau online. Okay, can you show me the mapping, please? Go to the map option on your menu bar, background images. Select injury data, yeah. Y and Y, see there? Mistake? No, cancel. Select it. Cancel this one. You click on that background body outline, you click on it. You will get, no. Okay, fine. See, edit option has become active. Click on edit. X field you have mapped to Y. All right, now it should come. Reduce the aggregation. Sum of X, you make it average of X on the columns shelf. I got it. You go to the columns shelf. Go to measure. Make it average. Similarly, Y also. Go there. Go to measure and make it average. Images. Now you have to change the fit. Go to standard option. Make it entire view. Now you see how the image is not right. Again, go back. Go to the map option on the menu bar. Background images. Yeah. Click that. Select the image. You should get that blue line. Select the image, not add image. We have already added the image. We want to edit it. So click on it. It will become an active edit. Go to Options tab now. Options. Lock aspect ratio. Right. Apply. You see, if you don't do lock aspect ratio, that is how image will get distorted. Okay, I'll take back the control. So are you all okay with this? For the morning session, is the link not shared with y'all yet? Oh, okay. I will have it sent to y'all. Okay, the link. Now what we will do it, we have, I hope all of you have been able to bring the image onto the canvas. The next step is, our requirement is not to bring the image onto the canvas. That is the basic thing. That is the first step. Our requirement is to show the injured body parts on this image. Show the injured body parts on this image with a data point and represent the number of injuries on each body part on the image. That is our requirement. Okay. So what we will do is we have to get the coordinates for each and every data point that we have to show here. Right now it is 99 and 325 over here. Let's say for injuries that have occurred on the head, I want to put a data point here. For injuries that have occurred on the eye, I want to put a data point here. For injuries that have occurred on the neck, I want to put a data point here. For injuries on the shoulder, I want a data point here. For injuries on the elbow, I want a data point here. Now, how do I put a data point like this? For this, we will use a concept called as point annotation. Point annotation. Okay, how do we do point annotation? You go to the place where you would like to represent a data point on the image. Go to the place where you want to represent a data point on the image, where you want to put a data point on the image. Right click. When you right click, you will get on the context menu, there's an option annotate. Go to annotate point. Point annotation by default will give you the X and Y coordinates itself. Okay, so we don't have to do anything here. Just click on OK. Point annotation will come. Make a note of it. Write down in a notepad. You can write down, okay, head X coordinate is 49, let us say, and Y coordinate is 318. Then go to that annotation, click and drag it to the next place. I, X coordinate is so and so, Y coordinate is so and so. Next, neck, X coordinate is so and so, Y coordinate is so and so. Next, shoulder, X coordinate, Y coordinate. Elbow, X coordinate, Y coordinate. Like that, you get the X and Y coordinates for each and every injured body part that you're trying to represent. After you make a note of all the X and Y, you can delete the annotation. Delete the annotation. And now comes the next part. So what did we do? First, we linked the image with the data source so that it comes to the canvas. After the image comes to the canvas, we do point annotation to capture the X and Y coordinates for the data points that we want to represent on that image. Once you have captured the coordinates, you have seen the coordinates, you obtained the coordinates, and you have written it down in a notepad. Now comes the point where we have to show the data points on those coordinates that we have taken. So we will update the formula. Initially, X was containing 99. Why did initially X contain 99? Because that is the width of the image. And we needed it so that the image comes onto the canvas in the first place. But once the image is on the canvas, our motive has changed now. Our motive now is to show the data points there, and those data points should have X coordinates. Those data points will have Y coordinates, right? Based on that, we put them on the XY coordinate plane. So we will replace 99 with the coordinates with the X coordinates for the different data points to be represented. I'm sending the formula on the chat. All of you take this formula, copy it, and go to Tableau. So, and edit X. Edit X. It need not be 99. It is supposed to contain the X coordinates for all the injured body parts. So When I'm using a case statement, which I think I already explained once in the training, I don't remember, but case is like this. If the injured body part, when the injured, we are evaluating the injured body part. When it is abdomen, then we'll use 50. When it is arm, then we'll use 10 as the x coordinate. When it is back, we are using 24 as the x coordinate, so on and so forth. Okay, so you're updating x and y to hold the x coordinates for the data points that are to be represented on the image. Okay, now average of all the values, new x values that we have given for each injured body part, new x values that we have given, average of this is coming up to be 41.7, and it came here. Similarly, we have to update y also. So how do we update y? With a formula containing the y coordinates, which I'm sending on the chat again. Okay, so today little extra I'm taking, please don't mind. We'll finish off this topic, okay, and complete the module. So y also you will edit. It need not be 325. Directly you can paste the formula. Instead of 325, you put the formula there. So when the injured body part is abdomen, then the y coordinate I want to use is 180. When the injured body part is arm, then the y coordinate 220. When the injured body part is back, then the y coordinate 260. Like that we are putting. Okay. Now we want to show for each and every injured body part, right? So we will take injured body part to color. That is how we can represent our data on a custom background image. But all the data points are of the same size. What is it that we want to do? We want to show the number of injuries that have occurred there. So what we'll do is we'll change the shape to a filled in circle, and we will take the count to size shelf. Size of the circle is going to represent the number of injuries. Okay. Next. Now from here on, whatever I tell is more with respect to formatting. So when you create a map, do you have axis, x-axis and y-axis? No, because it's not required. It's not even meaningful. Similarly, when you are representing the data on a background image, x and y not required. So you remove the x-axis and the y-axis by unchecking show header. And you can get rid of the zero lines. Okay, you can get rid of the zero lines. You can label it with the value that it is representing, etc. All right, so that is how you represent data on a customized background image. I think here we will stop. We have completed this module on geographical maps. If you have any questions with respect to anything that we discussed today, let me know. I'm available for the next 5 to 10 minutes. So even if when you're doing the hands-on activity, if you're not able to get it, let me know. I will help you. That's it from my side for today. Tomorrow morning, there is a session on Tableau online. I will forward the link to you all. I'm sending it on your WhatsApp group. So 22nd June 2020. I sent the message on WhatsApp in the group. So you can all attend this session on Tableau online. Yeah, Rani, just stay back. We will discuss. So as of now, I'll take up any questions on this example if anybody has. If all of you are okay with this example, then we will look at whatever the questions you have. Not in data science, it will not be shared, I think. I don't know. You want it there in your data science group, you want it to be published? Are you not there in the Tableau group, Ganesh? It has been sent to all the Tableau groups. All right, I'll inform Manish to send it to you, okay? All right, then. Okay, then I think I'm not getting any questions pertaining to the hands-on activity that we did today. I hope you're all okay. And I'm going to stop the recording and we'll discuss